Hello everyone, this is Smirin, and in this video we are going to be doing part 3 of our advanced programming in the toy box. And in part 3 we're going to be focusing on randomizers and a very basic logic chain. So randomizers are fairly simple. They seem complicated if you go into the properties, but I generally don't even go into the properties. That's only if you're doing something really complicated. So let's just find a randomizer and drop it down. What a randomizer basically does is in programming there is a random function which lets you randomize a number so that you can make things happen not always in the same order. You can randomize them. You can make it so next time that enemy will spawn instead of this enemy. So randomizer is how you do that in Disney Infinity. Now if you look under properties, these random triggers can look a little confusing, but basically I never touch these pretty much ever. What they let you do is say you have two possible random events you want to happen, but you want one of them to have an 80% chance to happen and the other a 20% chance. That's when you would come in here, set random trigger 1 to 8, random trigger 2 to 2, and there you have an 80% chance of random trigger 1 happening. But when I'm adding things, I usually want it all to have a pretty fair, even chance of happening. So I don't touch those. I let them, they actually auto-propagate as you attach things to the triggers. Each of them will set to the value of 5, and you're good. So the idea of what we're going to do here is we're going to make actually a few paths. And what we're going to do is have some townspeople walking down these paths. And so we're going to start a path, and I'm going to have one little point there, and then a point there, and we're going to end it. And then, over here, I'm going to put another path, which is basically going to curve around a bit, and come back close to this one. And I'm going to do the same on the other side. Come out a bit, curve back around, come back here, and go right about there. And then I'm going to do one more path, which is going to be right about here. And that path is going to go... Pretend you don't see that giant monster sitting down there. So the idea of what we want to do here is we want to spawn a bunch of townspeople, have them start walking down here, and when they get to this point, we want to randomly decide, let the game decide with a randomizer, do I want them to walk down this path next, or do we want them to walk straight? And we're going to actually be using a baby logic chain for that, because the problem is when you're linking a path to another path, if I said point reached by object on path, and then I said connect triggering actor to path, I can't do that with a randomizer because there's information in the game called triggering actor information, and trust me, we're going to do a video just on triggering actor information because it's an interesting one to try and explain when you're doing advanced things with them. It's very simple when you're just doing basically hook it up to a kill switch, but when you're trying to do advanced things, it's a little more complicated. There's only a few tools you can do advanced triggering actor information with. And of course, our lovely friend here, the logic gate, is one of them. So we're going to be building a logic chain. And before I discuss that, a logic gate is basically an if-then else statement. Now when you do a logic chain, what you're doing is you're attaching, and in this case I'm going to use the input block of the first one, and I'm making it send an input to the next one. So what you're doing there is we're going to be saying, we're going to be using this last point, reached by object, and we're going to be sending it to the first logic gate. I hope that's the first logic gate. Yes. We're going to be send it to the input of the first logic gate. And because we require triggering actor information for this, it has to be going into a logic gate or a time delayer. Again, I said I will explain all that later in another video. But what we're going to be doing is we have 3 separate paths we want to have the option of going down. With a logic gate, you only have 2 choices. You have output or input blocked. But if you link them together, you can increase how many choices you possibly have. In this case, when I have 2 logic gates chained together, I have a total of 3 possible choices I can use. And I don't have 4 because I've linked them together. I've used the input blocked of the first one to tie us to the second one. So the input blocked of the first one isn't a valid choice anymore. So basically, I can use the output of the first one, I can use the output of the second one, or I can use the input blocked of the third one for different possible choices. That gives us 3 choices by linking 2 logic gates. So what we're going to be doing here is we're going to be saying whenever an object reaches this point here, the point before the end, I'm going to tell the randomizer, pick a random choice here by selecting that action option. And what the randomizer is going to be doing is it's going to be saying, if it's trigger 1, I'm going to open that logic gate. If it's trigger 2, I'm going to open the second logic gate. And if it's trigger 3, I'm going to close the last logic gate. Now we're going to do something that I do a lot when I'm building logic chains, because technically I should also say random trigger 2 is closing this logic gate and random trigger 3 is closing this logic gate, because I need the signal to pass through this logic gate to get to the next one. What I do with logic chains is I go to the very end of the logic chain, the absolute farthest you can get from where the input signal is arriving into that logic chain, and I start working my whole way up with the following 2 choices to the logic gate 1 step closer to the input. I say if this logic gate opens, that means I need that logic gate at the top to be closed. And also, if this logic gate closes, I still need the logic gate above it to be closed. That way I only have to send the 1 signal specifically to the logic gate I'm looking at in the chain that I need to be open or closed, and I only have to send a signal to it, and the rest of the logic chain will close all the way up to the input to allow the signal to get there. Again, we'll go more into depth into logic chains later on, of course. So what we're going to say here is we're going to say, here's our 3 choices. An output from the first logic gate is going to connect our triggering actor to the path on the right. The output on the second logic gate is going to make us go forward, and the input blocked on the second gate is going to make us go to the right. Now this is going to work automatically because I haven't turned off the setting of auto start objects when connected. So when I connect them through the triggering actor connection there, they will automatically just walk over and start traveling down that next path. And the first path even has that option set on because I'm going to use an enemy or a friend generator to spawn the townspeople. And I'm also going to use, did I put a button down? I did put a button down. I'm also going to use a counter and a repeater. And the repeater, I'm going to have a townsperson spawn, let's say, every 2 seconds. And when it repeats, we're going to spawn. Who should we spawn? Oh, I know who we should spawn. Unfortunately, they're way down the damn list. I mean the list. I didn't say that. Don't know what you're talking about. So they're way down the list. So what we're going to be doing is we're going to be attaching this friend generator to that path so that any friend that is spawned on this path is instantly going to walk over to it and just start walking down it. Okay, so I'm going to move the generator just a wee bit closer, and I'm going to connect it with a path connection to the first path, so that when they spawn, they'll start walking down this path. When they hit this point, the randomizer will decide, by closing and opening logic gates here, which path they are then going to travel down when they reach this point on the path. So, alright, now also every time our repeater fires off, I want to increment this counter. I don't want this to go on forever, so I'm going to put this counter at a count of, let's say, 10. And once 10 MightyGitises have spawned, oh, let's keep that on just so we can see. Once 10 of them have spawned, we're going to turn off this repeater. And the only last thing we should have to do is, when I hit this button, turn on that repeater. So, let's see if it works. Pushing the button. MightyGitis number 1, number 2, number 3. Now I hope they're spaced far enough apart. Oh, so 2 of them went left, one went straight, another one went left, another one went straight. Oh, there's one going right. Those ones are headed to their doom. Now, did I hook these final path points back up? No, I didn't. Go figure. Point reached by object on main path. Connect triggering actor to path. And we'll do the same thing so that they start all over again instead of just looping as they're doing right now. There we go. So as you see, well, more and more are heading to their doom. One decided to go left there. This one's wandering in from who knows where. And there we go. So we have them randomly deciding whether they want to go left, right, or straight, all based on a randomizer and that little tiny logic chain we have there. And let's just ensure that they're acting. Oh, and this is the guy you get if you throw a few people in there. This wonderful little skeleton costume. So there we go. We have a system running where the townspeople are going to randomly decide what direction they're going. And every time they come back down this straight path, again, they will randomly decide where they're going to go, all based on this randomizer and these 2 logic gates here, which are chained together. So, again, this has been Sumerian. I hope this tutorial has been helpful to you and there's some useful information there. And if you need any help with anything, just let me know. Have yourselves a great day.